Welcome to the Explainer. All right, let's jump right in. We are currently witnessing a massive, fundamental shift in enterprise tech. We're talking about moving away from those simple conversational chatbots and stepping right into the era of autonomous AI agents. And honestly, with that shift, everything we thought we knew about cybersecurity is getting totally flipped on its head. Today, we're going to explore exactly why those old perimeter defenses are failing us and how we absolutely have to transition to controlling what we call the blast radius. Take a look at this question. Is our data safe in the cloud? Now, for the last decade, this has been the standard kickoff question in pretty much every executive boardroom. But here's the reality of this new agentic era. This question, it's entirely obsolete now. Why? Because the threat model has completely changed. Our biggest risk isn't some vendor secretly stealing our data to train a global superbrain. Nope. The real risk is that our very own AI agents are being handed way too much power, way too much autonomy, and honestly, far too little oversight.
Chapter 1. The new kickoff question.
Since AI isn't just answering our questions anymore, it's actively taking autonomous actions on our behalf, we've got to change how we evaluate risk from the ground up. If you're a senior leader today, there are 3 absolutely critical new kickoff questions you need to ask before greenlighting any AI project. First, if this agent gets compromised or just starts hallucinating today, what is the absolute first system it could reach? Second, if it starts doing something malicious, who exactly is going to notice within 24 hours and how? And third, what is your concrete, tested rollback plan to stop it? We have to shift our focus squarely onto the blast radius. Basically, if this agent explodes, how much of our infrastructure is it taking down with it? Chapter 2. What's really happening? So before we get into the threats, the good news is that major players, Microsoft, Google, Anthropic, Snowflake, they've largely solved the enterprise training privacy issue. Your data isn't being used to train their base models. The models are actually moving to where your data lives, which is great. But while we were all busy watching the front door, the back door blew wide open. 45%. That's the number of employees regularly using generative AI on corporate devices right now, according to the Verizon Data Breach Investigations report. Shadow AI usage has literally tripled year over year. Employees are pasting source code and regulated data into unauthorized, consumer-grade AI tools using personal accounts that your IT department just can't see and definitely can't lock. But here's the kicker. Even when you do everything by the book and deploy official, sanctioned AI tools, you run headfirst into this concept of permission amplifiers. Official deployments like Microsoft Copilot, for example, are designed to inherit every single permission a user already has. So they don't technically leak your data in the traditional sense. Instead, they make it incredibly trivial for, say, a junior intern to type a quick prompt and instantly uncover a highly confidential M&A folder that was accidentally left open to all employees 5 years ago. It really comes down to this. AI isn't picking your locks, it's just showing you which doors were left open. The root cause of these terrifying internal data exposures isn't some brand new AI technology, it's legacy IT hygiene. It's years of unchecked permission sprawl. The AI is simply acting as a giant flashlight, illuminating all the broken access controls your organization completely forgot about.
Chapter 3. Real risks versus myths.
We really need to separate the sensationalized boardroom fears from the hard operational realities that security teams are actually fighting on the ground. There's this persistent myth, fueled by some sweeping lawsuits, that all AI vendors are secretly pooling your private enterprise prompts into a single global data lake to train some massive competitor model. The reality? There is zero technical evidence for this in enterprise tiers. None. The actual reality is that leakage happens right in the architectural seams. It happens when an AI tool is misconfigured to run with owner privileges, totally bypassing your data masking policies. Or it happens when an attacker uses prompt injection, hiding malicious instructions in a web page or an email that your agent reads, effectively tricking it into secretly exfiltrating data right under your nose.
And you know what the most proven risk actually is? Plain old credential theft. Just listen to this quote from the Mandiant report on the massive UNC 5537 threat campaign. They investigated widespread breaches of cloud environments, and what did they find? Compromises caused by stolen customer credentials, not a breach of the core environment. The most common villain in an AI breach isn't some highly sophisticated rogue AI model like out of a sci-fi movie. It's a forgotten contractor's laptop that just didn't have multi-factor authentication turned on. Chapter 4. Zero Trust for Agents. So, how do we actually fix this mess? Well, we apply zero trust.
We have to fundamentally stop treating AI agents as simple software applications and start treating them as highly capable, highly autonomous, and high-risk employees. The foundational concept here, as defined by OWASP, is least agency. This takes the old-school concept of least privilege and applies it directly to autonomous systems. Think about it. If you deploy an agent to summarize an incoming customer service email, that agent should possess absolutely zero rights to send an email, modify a database record, or delete a file. It gets read-only access, tightly scoped to that exact task, and nothing else.
Anthropic recently released a comprehensive zero-trust framework for AI agents, and it boils down to these core pillars. First up, cryptographic identities. Every agent needs a unique, unforgeable ID so you know exactly which agent took which action. Second, task-scoped keys. We can no longer use static, shared API keys just sitting in configuration files. Agents must request short-lived tokens, keys that work for 10 minutes and only open one specific drawer. And finally, assume breach architecture. You have to design your systems assuming the agent's environment will eventually be compromised. You isolate them in sandboxes so that if an agent does go rogue, it can only burn down one single room, not the entire corporate house.
Chapter 5. The Leadership Roadmap.
All right, we've talked about the problem and the architecture. Now let's look at a highly actionable playbook for C-suite executives and boards to roll out over the next 6 months. In the next 30 days, your immediate triage is to map your agent blast radius. Go ask those 3 kickoff questions for every single AI project and aggressively inventory your shadow AI usage to find out where your code is leaking. In 90 days, you need to tighten identity. Get into your SharePoint and data lakes and systematically remove everyone access from sensitive internal sites. Rule of thumb, if an agent doesn't need to see it, a human probably shouldn't either. You also need to start implementing agent-aware guardrails to filter what goes in and what comes out. Finally, at the 180-day mark, you must formalize a zero-trust reference architecture. This means actively ditching shared API keys, implementing those cryptographic identities, and categorizing all your data into safe for AI and AI-restricted zones.
I want to leave you with this final, provocative thought to take back to your teams. AI isn't breaking your security, it is revealing it. Seriously, the vulnerabilities you're seeing today, they were likely there all along, just waiting to be exploited. The autonomous agents of tomorrow are going to move at machine speed, and those old perimeter walls simply won't hold them. The way you wire your agents today determines your security posture tomorrow. So the real question you have to ask yourself is, are you ready to stop building higher walls and start controlling the blast radius?